In this parallel circuit, the given are the VA is equal to 9 volts, the R1 is equal to 90 ohms, R2 is equal to 45 ohms, R3 is equal to 180 ohms. So find the total current, the total resistance I1, I2, I3, V1, V2, and V3. So the first problem that we're going to find is the total resistance. So total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 raised to the power of negative 1. So 1 1 divided by the R1 is equal to 90 ohms plus I plus 1 over 45 ohms plus 1 over 180 ohms raised to the power of negative 1. So the total resistance is equal to 25.7 ohms. Next is the total current. So total current is equal to total voltage over total resistance. So the total voltage is equal to 9 volts. Then the total resistance is equal to 25.7 ohms. So 9 divided by 25.7 is equal to 0.35 ampere or 350 milliampere. Then next is the I1. So I1 is equal to total voltage over R1. So total voltage is equal to 9. Then R1 is equal to 90. So 9 divided by 90 is equal to 0.1 ampere or 100 milliampere. Next is I2. So the total voltage is equal to 9 volts. The R2 is equal to 45 ohms. So 9 divided by 45 is equal to 0.2 ampere. So or equal to 200 milliampere. Next is I3. So the total voltage is equal to 90. Then the R3 is equal to 180 ohms. So 90 divided by 180 ohms is equal to 0.05 ampere or 50 milliampere. Next is the V1. So the formula in V1 is equal to I1 times R1. So I1 is equal to 0.1 times R1 is equal to 90. So V1 is equal to 9 volts. Next is V2. So V2 is equal to I2 times R2. So I2 is equal to 0.2 ampere times R2 is equal to 45 ohms. So 0.2 times 45 is also equal to 9 volts. Next is V3. So V3 is equal to I3 times R3. So I3 is equal to 0.05 ampere times R3 is equal to 180 ohms. So 0.05 times 180 is also equal to 9 volts. So in this figure, it is a combination of a parallel and a series circuit. So the given are the VA or the total voltage is equal to 90 volts, R1 is equal to 30 ohms, R2 is equal to 20 ohms, and R3 is equal to 25 ohms. So find the total current I1, I2, I3, V1, V2, and V3. So the first thing that we're going to find is the total current. So total current is equal to VA over RT. But before that, we need to find first the total resistance. So total resistance is equal to 1 over R1 plus 1 over R2 plus R3 raised to the power of negative 1. So we need to add this because it is on a series circuit. So in total, the total resistance is equal to 18 ohms. So we can now find the total current. So the VA is equal to 90 volts. The total resistance is equal to 18 ohms. So 90 divided by 18 is equal to 5 ampere. So next is I1. So the formula in I1 is equal to total voltage over the R1. So 90 volts divided by 30 ohms is equal to 3 ampere. So next is I2. So total voltage is equal over R2 plus R3 is equal to 90 over 45. So 90 divided by 45 is equal to 2 ampere. Next is I3. So it is on a series circuit. So on a series circuit, the current is equal. So the I2 and I3 are equal. So R3 is also equal to 2 ampere. So next is V1. So on a parallel circuit, the value of the total voltage is also equal to V1, V2, and V3. So in this problem, V1 is equal to 90 volts. Next is V2. So V2 and V3 are on a series circuit. So we need to find first the their current. So their current is equal to 2 ampere. So V2 is equal to 2 times the R2, which is equal to 20 ohms. So 2 times 20 is equal to 40 volts. Next is V3. So their current is equal to 2 times the R3, which is equal to 25 ohms. So 2 times 25 is equal to 50 volts. So on a parallel circuit, the value of the total voltage is equal to V1, V2, and V3. So the total voltage is equal to 90, the V1 is equal to 90. Then it is on a series circuit, so we need to add this. So 40 plus 50 is also equal to 90 volts.